time t equal to 2 seconds, you have to substitute in the velocity equation. First, what is velocity? Velocity is equal to, already just before we done. So what is the velocity equation? 8t plus 1. 8t plus 1. After differentiating the displacement once, you get the velocity. So velocity equation is 8t plus 1. So put the t value 2. That is, you get the velocity at 2 seconds. 8 into 2 plus 1. How much? 16 plus 1? 17 meter per second. This is the second question. Similarly, third question. What is third question? Acceleration. What is acceleration? Nothing but acceleration. Nothing but already just we done here. So what is acceleration? Acceleration nothing but dv by dt. After differentiating dv by dt, we did not get any time function. So acceleration, if you differentiate, okay, the above equation, again you will get the same value. That means the acceleration at second also, that is 8 meter per second, because it is independent of time. So this is the way you have to solve the problem. If the wave particle is having variable displacement with respect to variable time function, then we can go for differential way of method to solve the problem. Now we'll go to the little bit, okay, next level of question in this, so that we can able to complete the thing. Only one more. After that we'll go for integration method. So in this same question way, a particle is moving in the space with a displacement x equal to, okay, otherwise sorry, I will give a different question. Okay, the particle is moving in the space as a given function, time t is equal to x squared minus 1. This is the way the function is given. So the question is, what is the velocity at 3 seconds? What is the displacement at 3 seconds? What is the acceleration at 3 seconds? That means after 3 seconds of the journey, what is the velocity, displacement, acceleration we need to calculate. First, velocity. First question to solve it. Velocity at 3 seconds to calculate. First, you have to know that velocity is equal to dx by dt. Yes or no? Rate of change of displacement called as velocity, dx by dt is velocity. So you take this is d by dt of x is what? Displacement. What is the displacement? Not given. Time is given. Time is variable with respect to x. That means x value changes automatically, t value also changes. So what we have to do is, first we have to write this equation, given equation in terms of our understanding equation. T is equal to x square minus 1. X square minus 1. Can I write this equation like this? X square is equal to t plus 1. I can write. Next, x equal to what I can write? That is t plus 1 whole power 1 by 2. So x value equation we got. Now this x value changes time to time. According to that one, I can write this in the place of x, what I can write? That is t plus 1 whole power 1 by 2. Now we have to differentiate this one. That is only the task of doing here in the main questions. Whatever the way the differential functions are given, we have to solve it. So v3 is equal to, now this is in the form of d by dt of d by dx of x power n formula. In the place of x, what we have? T plus 1. In the place of n, what we have? 1 by 2. Formula is n into x power n minus 1. What is n formula? 1 by 2 into, okay, x in, that is t plus 1 whole power n minus 1. Okay, n into x power n minus 1. What is n value? 1 by 2, that is minus 1. This is the way you have to solve it. So if you differentiate this one, what is the equation you are going to get? That is 1 by 2 into, that is t plus 1. Okay, 1 by 2 minus 1. How much you are going to get? Minus 1 by 2 you will get. So if you solve this one, you are going to get 1 by 2 into, that is t plus 1 whole power 1 by 2. Minus 1 by 2, if you make it to denominator, it becomes plus 1 by 2. Okay, this is the way you get. Now what time they are asking? At time of 3 seconds they are asking. Put the t value 3 here. So v3 is equal to, that is 1 by 2 into, that is 3 plus 1 becomes 4 whole power 1 by 2. So this is nothing but 1 by 2 into 4 can be written as 2 square into, okay, that means otherwise 4 power 1 by 2 means root 4. Root 4 value how much? 2. That is nothing but 1 by 4. So speed is equal to 1 by 4 meter per second. That is nothing but 0.25 meter per second. You can able to explain the answer. Similarly, what is the next question? Next question is displacement. What time they are asking? 3 seconds. What is the displacement? First already we got the displacement equation. How much? That is t plus 1 whole power 1 by 2. This is the equation we got. Now put the value of t here. So x3 is equal to, that is nothing but 3 plus 1 whole power 1 by 2. So that is equal to x3 is equal to 4 power 1 by 2. You get that is nothing but 2 meters is the answer to the question. So this is the way you get the displacement. Similarly, what is the acceleration? Third question. The acceleration, third question is given here. A is equal to at third second. To get that one, we have differentiate this velocity with respect to time. So d by dt of v3. So d by dt of velocity. What is the velocity equation? Just we got here velocity equation. This is the velocity equation. So that velocity equation you take it, that is nothing but 1 by 2 into 1 by 2 into t plus 1. T plus 1 whole power minus 1 by 2. So now you solve this one. A3 is equal to 1 by 2 is constant, no differentiation, take it outside. Differentiation of this with respect to t plus 1. Now you consider this one as x, this one as n. So if you consider like that, what happens? It becomes d by dx of x whole power n. Again, n into x power n minus 1 is the formula for that, right? So you can write it. That means this is the function. Okay, it is in the form of x power n, differential function of x power n. Where the differential function of x power n formula? N into x power n minus 1. Apply that one. If you apply this one, what is n value here? N value is minus 1 by 2. What is x value? T plus 1 whole power minus 1 by 2. Okay, n into x power n minus 1, right? That is nothing but minus 1. Already we have a power minus 1 by 2. Okay, that is I taken here, and t plus 1 whole power minus 1 by 2 minus 1. If you solve this one, you take minus before, so this is 1 by 4 you will get, and this equation you are going to get t plus 1 whole power minus 1 by 2 minus 1. How much you are going to get? That is minus 3 by 2 you are going to get. Minus 3 by 2. So now in this case, this equation you can make it to denominator. What way I can make it to denominator here? This is the acceleration per second to calculate. Here minus, keep it like that, minus 1 by this t plus 1 whole power minus 3 by 2, make it to denominator. That becomes t plus 1 whole power plus 3 by 2 you get. Yeah, this is the way you get the acceleration at third second. Now not third second, at any time, right? So put the t value now 3. You get exactly at 3 seconds, that is minus 1 by t value how much? 3. That is 3 plus 1 whole power 3 by 2. So 3 plus 1 whole power 3 by 2 how much? A3 is equal to, that is nothing but 1 minus 1 by 4 power 3 by 2. That becomes 2 cube you will get. Yes or no? 4 whole power 3 by 2. 4 means I can write as 2 square whole power 3 by 2. Okay, the square and root cancel, that is 2 cube you will get. What is the 2 cube value? 8, that is 1 by 8 meter per second square is the answer for your question. This is the way you have to solve the questions. As the mathematical equation changes, automatically the differential functions formulas also changes. Some functions in the form of differential function x into u form, some are x by y form, some are x minus y form. So according to the problem, you have to be perfect in the differential equations, then you can apply to the physics to solve the problems. Okay, next model we go for integration model. So the question is given in this: a particle is accelerating in the space as a function a is equal to, given as 3t square plus 1. Simple equation I am taking, 3t square plus 1. This is acceleration of the particle given. Using this particle acceleration, we are asking to find what is initial displacement of the particle, what is initial velocity of the particle, what is initial acceleration of the particle. So here, before we got the displacement, after differentiating once we got the velocity, again differentiating we got the acceleration. Now in this case, we have to follow the reverse way. What reverse way we have to follow here? First, to get the, first you calculate the acceleration first. Initial acceleration is equal to, what is the acceleration equation given? That is 3t square plus 1. Initial means what time they are asking? At time t equal to 0, called initial condition. So put the t value 0, directly you will get initial acceleration, that is a naught. Okay, a naught is equal to, or otherwise a I is equal to, how much you get? 3 into t value. If you put 0, 0 plus 1 is equal to 1 meter per second square you get. So initial acceleration of the particle, how much you got? 1 meter per second square. Now go to the reverse. Second, this is which question? That is velocity. What is initial velocity? First find the velocity, then after we will go for application of time t equal to 0 for initial condition. So how to find the velocity? You know that acceleration is equal to dv by dt, right? But acceleration is given, velocity is not given. So velocity is only we need to find. So differential function is in the velocity. So what we will do is mathematically the dt, make it this side. Now that becomes a into dt is equal to dv. I can write. Now here acceleration changes with a function of time, so velocity also changes. So acceleration to time gives the velocity. So now we have to do integration both the sides. Now apply the integration here. So I write in my order, that is integral dv is equal to integral a into dt. We can write integral dv according to integration, that is we will get velocity v. Now in this case, what is right hand side? Right hand side is a dt. What is the acceleration? What is the acceleration equation given? That is 3t square plus 1 into dt they given. So now integral, apply this dt to the both the terms, this first term, second term, both you apply, that becomes 3t square into dt plus, okay, 1 into t anyway, dt integral you will get. Now if you integrate this one, 3 is constant, not having any integration, that you have to know before solving this one. Now this is integral, that is t square dt you get, plus integral dt formula is simply t. So now this is t into t square dt. Now what is t square dt? Integral. So this is the formula, you have to know that. Integral x power n dx equal to, that is x power n plus 1 by n plus 1 is the formula. Apply this one. In the place of x what we have t, in the place of n what we have 2. So if you apply here t power 2 plus 1 by 2 plus 1, you get the answer. Okay, plus t. So integral dt is equal to t you get. Yes, sir, already we just got that one. Now next step, what I can say? So simply add, say, okay, that is velocity v is equal to 3 into, this becomes how much? T cube by 3 plus t. So this 3 get cancelled. So we are going to get the equation, that is t cube plus t. So this is the velocity equation at any instant of time in terms of time function. So now we are asking to find initial velocity, that is nothing but v naught. So put the t value 0 here. If you put the t value 0, both are going to get 0 plus 0, anyway that becomes 0 meter per second. So initially the particle is starting from rest, we can able to compute. Next, third question. For the third question is given displacement. Initial displacement they are asking to find. Okay, here we got the velocity now. So you know that velocity is equal to dx by dt. Right, velocity equal to dx by dt. So you can write this one in terms of like dx equal to v into dt, same like previous. Now integrate both the sides. Okay, this dt cross multiply, here you will get v dt, dx equal to this. Now integral dx formula. What is integral dx formula? We have to know before, that is x. Now next integral, what is v? Velocity. Velocity in terms of time function is given basis, that is t cube plus 3, t cube plus t, that is nothing but t cube plus t bracket into, we have a dt here. So this dt you can apply for the both the terms. If you apply for the both the terms, x equal to what you are going to get? Integral, that is t cube dt plus integral t dt. Two equations you are going to get. After solving this one, we will get the required answer, that is in terms of time function x equal to integral t cube dt. I am writing as t power 4 by 4 because it is in the form of x power n. Just before we written the formula x power n plus 1 by n plus 1 plus integral t dt. This is nothing is there means 1. 1 means it is also x power n form. In the place of x we have a t, in the place of n we have 1. So if you differentiate this one, we are going to get t squared by 2. So if you solve this one, x equal to how much you are going to get? T square by 4 plus t square by 1. So if you want to calculate initial displacement, means x equal to 0 condition means time t equal to 0 you have to put. If you put the 0 value here, 0 plus 0 totally will become 0 because 0 by anything is 0. So from this we have to understand that particle initial displacement is 0, initial velocity also 0, but having acceleration value, how much acceleration we got? Check that one, how much acceleration we got just before we calculated 1 meter per second square. So acceleration is 1 meter per second square. So this is the particle which is having initial displacement, initial velocity 0, but having acceleration. Like this you have to solve the integration model problems. Next class we will discuss related to similar model, some other questions we will discuss on this differential function and integration. Okay, that's it for today.